Hello students, let's discuss about online analytical processing server. Online analytical processing server OLAP is based on multidimensional data models. It allows managers and analysts to get a piece of deep information through fast, consistent and interactive access to information. In this topic, we can discuss about various types of OLAP, operations on OLAP and the difference between OLAP and statistical databases and OLTP. Various types of OLAP servers. OLAP has 4 types of server which are listed below. Relational OLAP, which is nothing but ROLAP, multi-dimensional OLAP, MOLAP, hybrid OLAP, HOLAP and specialized SQL servers. Next, we can discuss about relational OLAP. ROLAP is relational online analytical processing model where the data is stored in a relational database. For example, rows and columns in the data warehouse. In ROLAP model, data was present in front of the user in the multidimensional form. To display the data in multidimensional views, a semantic layer of metadata is created that maps dimension to the relational tables. Metadata also supports the aggregation of the data. Whenever the ROLAP engine gets a request, analytical server issues a complex query. It fetches data from the main warehouse and dynamically creates a multidimensional view of data for the user, and it differs from MOLAP because MOLAP already has static multidimensional view of data stored in proprietary databases MDDBs. As the multidimensional view of data is created dynamically, it processes slower in comparison to MOLAP. ROLAP engine deals with large volume of data. Relational online analytical processing ROLAP is a form of online analytical processing that performs dynamic multidimensional analysis of data stored in a relational database rather than in a multidimensional database, which is usually considered the OLAP standard. ROLAP uses relational database and it requires more processing time or disk space to perform some of the tasks that multidimensional databases are designed for. However, ROLAP supports larger user groups and greater amounts of data and is often used when these capacities are crucial, such as in a large and complex department of an enterprise. Relational OLAP servers are placed between relational backend server and client front-end tools to store and manage the warehouse data. ROLAP includes number 1, implementation of aggregation navigation logic, number 2, optimization for each DBMS backend, and number 3, additional tools and services. The major advantages of ROLAP servers can be easily used with existing relational database management system. Data can be stored efficiently and no zero facts can be stored. ROLAP tools do not use pre-calculated data cubes, and DSS servers of MicroStrategy adopts the ROLAP approach. The disadvantages of ROLAP are number 1, poor query performance, number 2, some limitations of scalability depending on the technology architecture that is utilized. Next, we can see about multidimensional OLAP. MOLAP is a multidimensional online analytical processing model. The data was used to analyze and is stored in specialized multidimensional databases. It is nothing but MDDBs. The multidimensional database management systems are proprietary software systems. These multidimensional databases are formed from the large multidimensional arrays. The cells or data cubes of this multidimensional databases will carry pre-calculated and prefabricated data. The proprietary software systems create this pre-calculated and fabricated data while the data is loaded to MDDBs from the main databases. Now, it is the work of MOLAP engine. It will reside there in the application layer and provide the multidimensional view of data from the multidimensional database to the user. Thus, when a user requests for a data, no time is wasted in calculating the data and the system responds fast. It is the more traditional way of OLAP analysis. In MOLAP, data is stored in a multidimensional cube. The storage is not in the relational database, but in proprietary formats. Multidimensional OLAP uses array based multidimensional storage engines for multidimensional views of data. The storage utilization may be low if the data set is sparse. Most of the MOLAP servers use two levels of data storage representation to handle dense and sparse data sets. Let us discuss about the advantages of MOLAP. MOLAP allows the fastest indexing to the pre-computed summarized data. Next advantage is MOLAP cubes are built for fast data retrieval and they are optimal for slicing and dicing operations. Next, MOLAP can perform complex calculations. All calculations have been pre-generated when the cube was created. So, complex calculations are not only doable, but also they return quickly. The next advantage of MOLAP is MOLAP helps the users to connect a network who need to analyze larger and less defined data. It is easier and suitable for inexperienced users. The disadvantages of MOLAP are MOLAP is not capable of containing details of data. The storage utilization may be low if the data set is sparse. Next, we can discuss about the key differences between ROLAP and MOLAP. If we consider ROLAP, it stands for Relational Online Analytical Processing, whereas MOLAP stands for Multidimensional Online Analytical Processing. In both cases, ROLAP and MOLAP data is stored in the main warehouse. In ROLAP, data is directly fetched from the main warehouse, whereas in MOLAP, data is fetched from the proprietary databases MDDBs. If we consider ROLAP, data is stored in the form of relational tables, but in case of MOLAP, data is stored in the form of a multidimensional array made of data cubes. ROLAP deals with large volume of data, whereas MOLAP deals with limited data summaries kept in MDDBs. Next, ROLAP engines use complex SQL to fetch data from the data warehouse, but in case of MOLAP, MOLAP engine creates prefabricated and pre-calculated data cubes to present multidimensional view of data to a user. To manage data sparsity in data cubes, MOLAP uses sparse matrix technology. ROLAP engine creates multidimensional view of data dynamically, whereas MOLAP statically stores multidimensional view of data in proprietary databases MDDBs for a user to view it from there. As ROLAP creates a multidimensional view of data dynamically, it is slower than MOLAP, which do not waste time in creating a multidimensional view of data. Next category is hybrid OLAP. Hybrid online analytical processing (HOLAP) is a combination of relational OLAP and multidimensional OLAP, usually referred to simply as OLAP. HOLAP was developed to combine the greater data capacity of ROLAP with the superior processing capability of the OLAP. HOLAP can use varying combinations of ROLAP and OLAP technology. Typically, it stores data in both a relational database, which is nothing but RDB, and multidimensional database, which is nothing but MDDB, and uses whichever one is best suited to the type of processing desired. The databases are used to store data in the most functional way. For data heavy processing, the data is more efficiently stored in the RDB, while for speculative processing, the data is more effectively stored in an MDDB. HOLAP user can choose to store the results of their queries into the MDDB to save the effort of looking for the same data over and over again, which saves time. This technique is called materializing cells. Actually, it improves performance and it takes a toll on storage. The user has to strike the balance between performance and storage demand to get the most out of HOLAP, but it offers the best features of both OLAP and ROLAP. HOLAP is increasingly preferred. HOLAP technologies attempt to combine the advantages of MOLAP and ROLAP. For summary type of information, HOLAP leverages cube technology to improve the performance. When detailed information is needed, HOLAP can drill through the cube into the underlying relational data. It offers scalability of ROLAP and faster computation of MOLAP. HOLAP servers allow storing large data volumes with detailed information. The aggregations are stored separately in MOLAP store. And the final category is specialized SQL servers. Specialized SQL servers provide advanced query language and query processing support for SQL queries over star and snowflake schemas in a read-only environment. Next, let us discuss about various OLAP operations. OLAP servers are based on the multidimensional view of data. The following is the list of OLAP operations. Number 1, roll up. Number 2, drill down. Number 3, slice and dice. Number 4, pivot or rotate. Next, we can discuss how roll up works. Roll up operation performs aggregations on a data cube in any of the following ways: by climbing up concept hierarchy for a dimension, by dimension reduction. The diagram illustrates how roll up works. Roll up is performed by climbing up to the concept hierarchy for the dimension location. In the example given in the diagram, initially the concept hierarchy is street followed by city followed by province followed by country. On rolling up, the data is aggregated by ascending the location hierarchy from the level of the city to the level of the country. The data is grouped into cities rather than countries. When roll up is performed, one or more dimensions from data cube are removed. Next comes the drill down operation. Drill down is the reverse operation of roll up, which we discussed now. It is performed in the following ways: by stepping down a concept hierarchy for a dimension, by introducing new dimension. The diagram illustrates how drill down works. Drill down is performed by stepping down to the concept hierarchy for the dimension time. In the given example, Initially, the concept hierarchy is day followed by month, followed by quarter, followed by year. On drilling down, the time dimension is descendant from the level of the quarter to the level of the month. When drill down is performed, one or more dimensions from the data cube are added. Drill down will navigate the data from less detailed data to highly detailed data. The next operation is slice. The slice operation selects one particular dimension from the given cube and provides a new subcube. The diagram shows how slice works. Here, the slice is performed by the dimension time using the criterion time equal to q1. It will form a new subcube by selecting one or more dimensions. And next operation is dice. Dice selects two or more dimensions from a given cube and provides a new subcube. The diagram shows the dice operations. The dice operation on the cube based on the following selection criteria involves in 3 dimensions: location equal to Toronto or Vancouver, time equal to q1 or q2, item equal to mobile or modem. Next, we can discuss about pivot operation. The pivot operation is also known as rotation. It rotates the data axes in order to view and provide an alternative presentation of data. The diagram shows the pivot operation. Next topic is OLTP. OLTP, it is nothing but online transaction processing. OLTP is a class of software program capable of supporting transaction oriented applications on the internet. OLTP systems are used for order entry, financial transactions, customer relationship management, it is nothing but CRM, and retail sales. Such systems have a large number of users who conduct short transactions. Database queries are simple, it requires sub-second response time and returns relatively few records. An important attribute of an OLTP system is its ability to maintain concurrency. To avoid single point of failure, OLTP systems are often decentralized. Coming to the difference between OLAP and OLTP, next let us discuss the difference between OLAP and OLTP. OLAP involves historical processing of information, whereas OLTP involves day-to-day processing. The second difference is OLAP systems are used by knowledge workers such as executives, managers and analysts. OLTP systems are used by clerks, DBAs or database professionals. OLAP is useful in analyzing the business, whereas OLTP is useful in running the business. The next difference is it focuses on information out, whereas OLTP focuses on data in. Fifth difference is OLAP is based on star schema, snowflake schema and fact constellation schema. OLTP is based on entity relationship model. Sixth difference is OLAP contains historical data, whereas OLTP contains current data. Next, OLAP provides summarized and consolidated data, whereas OLTP provides primitive and highly detailed data. Next, OLAP provides summarized and multidimensional view of data, but OLTP provides detailed and flat relational view of data. Number of users is in hundreds in case of OLAP. Number of users is in thousands in case of OLTP. In case of OLAP, number of records accessed in millions. In OLTP, number of records accessed is in tens. OLAP database size is from 100 gigabytes to 1 terabyte, whereas in case of OLTP, database size is from 100 MB to 1 gigabyte. OLAP is highly flexible, but OLTP provides high performance. To conclude, online analytical processing OLAP databases facilitate business intelligence queries. OLAP is a database technology which is optimized for querying and reporting instead of processing transactions. The source data for OLAP is online transactional processing databases that are commonly stored in data warehouses. OLAP data is derived from this historical data and aggregated into structures that permit sophisticated analysis. OLAP data is also organized hierarchically and stored in cubes instead of tables. It is a sophisticated technology that uses multidimensional structures to provide rapid access to data for analysis. This organization makes it easy for a pivot table report or pivot chart report to display high level summaries such as sales totals across an entire country or region, and also to display the details for sites where sales are particularly strong or weak. Thank you.